Now that you know how to obtain data from your colorimeter, let's take a look to some aspects you can explore during the present set of experiments. First, let's talk about how to choose a proper wavelength. You have already noticed that there are 4 different numbers in front of your colorimeter. Every number is a wavelength and corresponds to a different color of light, hence the name colorimeter. You can change the color by pressing the arrows on the blue circle. Do not forget to recalibrate after you have changed to a different wavelength. Every sample you are provided with have a different color and absorb light at a different wavelength. In the graph, you can see an example. It is clear that the green light gets absorbed the most, while blue light have almost no absorbance. Which color of light then you must use for your sample? Think about it. Do you want a wavelength that is highly transmitted or one that have low transmittance? You should test every wavelength for every one of the samples. Do you think it would be interesting to study the variation of wavelength with transmittance? What can a graph of percentage of transmittance versus wavelength tell you? Now, let's see some hints on how to analyze your data. When you try to find a relationship between cause and effect, it is always better to have a straight line. In this case, we want to find a function f that is linear with respect to the concentration C. Some examples for f can be seen below the graph. In the book, you will find 6 different possibilities. You should test every one of them. Let's see how. Well, we are going to see how to do the data analysis. First, we are going to mark our data to do our chart. We go to chart and we choose the XY scatter. That is what normally we have been using for this cause and effect. Now we are going to insert the statistics, and we can see that there are different types of regression. There is the linear, there is the logarithm, there is the exponential, and there is a power regression. We are going to use the linear, as we said before, and we can see the line that is adjusting our data. From the properties, we can obtain the equation for this line and the correlation coefficient. The correlation coefficient tells us how good is our graph. Maximum is 1, so a 0.93 doesn't look that bad, but I am sure that you can do it better. So let's see an additional example. We are going to use the percentage of transmittance square to see if we can find a better fit for our data. So we have our column of concentration that is going to be the same, and now we have the column of percentage of transmittance square. So to do that, we do the equation, we square the value, the first value, and now we just going to fill out the column. This is done by the program automatically, so the program does it for you. Now we're just going to repeat again what we did before. We mark our data, we go to chart, and we choose the XY scatter. Well, now we have our XY scatter. We go to statistics and find the linear regression. We can see the line now, and just looking at it, the line is not very good. It doesn't correlate very well with the data. So we look at the equation, we look to the correlation coefficient, and we see that the correlation coefficient is now 0.81. So it's smaller than before. That means that this data, this set of data, are less linear than before. What you have to do is find a better fit with the other equations.